All right, starting off 2-1 angles and congruence. We're going to be analyzing figures and calculating angle measures, looking at adjacent, linear, and vertical angles. So today, let's see, pulling up my notes so that I can see what you guys have at the same time. We're going to be looking at a lot of definitions today. So reminding you guys what a ray is. And we learned that right away at the beginning. A ray is part of a line starting with the end point going indefinitely on. So remember that like this one started at A and it's going on either through, you could say it's going through B or C. So you could call that A going through B or A going through C, right? Ray AB or ray AC. And it always has to start with its beginning point and then going on. Okay. Now, we didn't write that on our notes. That was just a reminder. But now we're going to talk about some of these other things here. Two collinear rays with a common endpoint are opposite rays. So remember, collinear means together on a line. So if two rays are together on a line with a common endpoint, they must be opposite rays. And then opposite rays form a straight angle. Now, we would typically call those a line. A straight angle is a line. It has a measure of 180 degrees. So if you're taking notes, you could write that that's a line, 180 degrees, right? Okay. Now there are three other kind of major angles that we really need to talk about, and we're going to write those down right now. And you've got three other spots for them. I don't have spots for them on mine, so I have an empty spot right here that I am going to write about them right now. One is going to be a right angle, and I bet you guys all know what that is. A right angle is an angle that sits at 90 degrees. 90-degree angle, okay? And when it's 90 degrees, we mark it with this symbol right in the corner. That symbol there, that symbol indicates perpendicular, okay? So 90 degrees. All right. So this would be my example, and my notes would be just 90 degrees. I think we all know what a right angle is. All right, an acute angle is going to be any angle less than 90 degrees. Okay, so this would be an acute angle. This would be an acute angle. This would even be an acute angle. An 89 degree, 89.9 degrees. 89.999 degrees is acute. 0.001 degrees is acute. Any of those, okay? And an obtuse angle is going to be an angle greater than 90. Typically, honestly, when we're looking at it, we're looking at, be even more specific, let's call it an angle X. It's going to be greater than 90 degrees, typically less than 180 degrees. It's going to be sitting between there, okay? Because we've got a straight line, that's a straight angle we talked about, that's straight, okay? It's going to be less than a straight angle. There we go. But it's going to be greater than a right angle. Those are both obtuse angles. All right. So hopefully you've got some notes on there. If you need to, you can pause me and keep taking notes. Otherwise, I'm going to go back up. Okay. So an angle is a pair of rays that have a common endpoint. So for this one, we've got a ray going out that way, a ray going out that way, and they form this angle in here. And how we label these angles, we have a couple ways to name them, actually 3 ways to name them. We can name them by their vertex if it's straightforward. So in this scenario, we can call it angle A, and we name it with this symbol right here. This symbol means angle, okay? However, we would not be able to do it if it was possible to misinterpret it. So for instance, if we had something like this, and we had multiple points on here, and it said A, B, C, D, we could not call this angle would not be called angle A, because this angle could be angle A, or this angle could be angle A. It's not clear which one's angle A. So the only time you can call an angle by its vertex is when it is straightforward, when there's only one angle, and it is always the angle that is less than 180 degrees. So what I mean by that is in this scenario, it has got to be this side. You can't say it's all the part on this side, what we would call the exterior of that angle. So it's going to be the interior of the angle is angle A. Okay. Now, another way to do it is by road mapping it. So we could say angle, and then you draw it out by naming 3 points. So you name it with 3 points. And the middle point is the vertex. So it would be, you could name it DAB. So if I were to trace that, I would be DAB. I'll grab a DAB. Or I could go DAC, same angle. Or I could call it CAD, same angle. I could call it BAD, same angle. It's still tracing the same angle, because they do go on infinitely. An angle would go on infinitely. So all of these are ways to name the same angle with 3 points. Note that A is in the middle of all of them. Now there's one other way to name an angle that's not listed so far. And it is, we could number it. We could put a number right here, put like the number 1, and then we could just call it angle 1. We see that sometimes too. Okay. All right, down we go. All right, rays are called sides of the angle. The common endpoint is the vertex. So, whereas we used to call this array and this array, we're now going to call them sides. Side AD, side AB. they're still appropriately called rays as well. And then this is our vertex. Vertex. And this is not a part on your notes, but points D, A, B, and C lie on the angle. Now an angle divides into three distinct parts. The parts that are on the angle, that D, A, B, and C, that would be one part. The other two parts are the interior and the exterior. The interior is everything that is in the less than 180 degree area. So that would be here. So if you were to measure this angle, it's going to be less than 180 degrees. And then the exterior would be where the angle is greater than 180 degrees. That would be out here. And in here, they show you these points are in the interior and these points are on the exterior. Okay. So in this example, they want you to name all the angles that have D as a vertex. So if I was doing this, I would go find D and I would start tracing lines. So you would find a ray. Here's a ray. There we go. And find another ray. And I would name that. So my points, let's see. I can't name it angle D because there's multiples there, but I could call that angle FDC. That's a good name for it, yep. Now I'm going to erase one of those and I'm going to go ahead and do that one. That's angle FDH. Let's see, what else could I do? They told me I could do straight angles, so I would go out that way. Angle FDG. Okay, and up this way. There you go, angle FDE. And that was just keeping it F. So now if I erase F and keep E, I can go out there, I can go out there, I can go out there. So there's actually like 12 different ones. So I'm not going to name all the angles. That's quite a lot of angles. I'm going to leave that be. Name the sides of, oh, that's supposed to say angle 2. So I'm going to write that back in, angle 2. Name the sides of angle 2. So I'm going to go find angle 2. There it is. And sketch angle 2. I like highlighting. There it is. Okay, the sides are the same thing as rays. The sides are rays. So this ray starts here and it goes out. So it starts at point B, goes out through A, and it is a ray. And the other side starts at B, and it either goes through D or G. And you can name either one. It doesn't matter with me. You could do BD or you could do BG. Doesn't matter to me. Next one, name a point in the interior of angle FDE. So let's erase what I was working on over here. Name a point in the interior FDE. So we're going to trace that FDE. Interiors are always less than 180, so that would be over here. So what points do I have in the interior? Well, F, B, D, and E are on that angle, but on the interior, I only have 1 point. Oh, and that's in the wrong spot. There we go. Put that up there. A. And last, name all the points on the exterior of FDE. Well, that would be all the points out here. And that's going to be C, H, and G. And that's how I would go about doing these. Okay. So now they're going to have you practice. And all of my stuff disappeared, but you've got them in your notes. Use the figure to identify the angles or parts of angles that satisfy the given condition. You need to know. Go ahead and pause me, and then I will show you the answer. And you should have come up with A, D, and E. All right. And now you can go on and do those topics right there.